Welcome to Crack It. In today's video, we'll be discussing into the actual interview questions that was asked during a screening round for a candidate with a 3 year of experience in my organization. So while these questions are considered really basic, they play a very crucial role in determining whether you progress to the second round. This is because many of us will not anticipate basic questions and maybe we will be unprepared. So I recommend watching this video to familiarize yourself with the fundamental questions which serves as a strong foundation for your preparation. So these are the live interview questions which was asked. Let's start the discussion. What do you mean by public, private and protected? Okay, public, private and protected or the access modifiers, and if I want to restrict the scope of a class, variable, method or a data member, then I'll use these access modifiers in front of these class, variables, methods or the data members. So other than public, private and protected, we have something called default. If we didn't define anything, if we didn't define any access modifier, then that is considered as default. Default has no keyword, and the data members, classes or the methods that are not declared as one of these are considered as default. And for default, uh, it is accessible only within the same package. So if suppose I didn't define any access modifier to a class, then that class will be accessible only within the same package, and if anyone outside that package tries to access that class, then they will not be able to access it. So default is accessible only within the same package. Then comes the private. So the methods or the data members that is declared as private or accessible only within the class. If you see here, it's methods and the data members. So we for the top level classes, we won't be able to use this private keyword because private is only defined for that specific class. So we can't define a private keyword to a top level class, but we can use private to the nested class, but not to the top level class. Next is protected. The methods or the data members declared as protected or accessible within the same package or subclasses in the different package. Even if the subclass is in different package, yes, it will be able to access the methods or the data members. Next, the public. It has no restriction. Public has no restriction on the data members, classes, methods or data members that are declared public or accessible from everywhere, anywhere, from anywhere, different package, same package, from anywhere you can use this classes, methods or data members that are with public access modifier. So next is the follow-up question of the previous question, which is nothing but have you ever used public in your application, and if so, in what are the instances you have used this public access modifier in your application. So this question is to test whether you know when to use this public keyword, or to check your knowledge on how deep you understand the access modifiers. So it is really essential, it's really necessary to expose this public keyword only if it is required. If not, use the other access modifiers. It is because public provides maximum visibility, so it's always essential to use the public access modifier judicially, considering the design and encapsulation principles of your application. So let's see where and all I have used public keyword in my application is on the class level. So when will I use public on my class level? So on it, if it is an API or a library class that needs to be accessible from the other packages, I will use public. Utility classes such as constants that I need to define for though all such principles, or a common methods that I have for all the utility classes, or the interfaces or the classes that needs to be reused across the different parts of the application or even in the other applications. For all these scenarios, I will use public keyword on top of my class. So when will I use this public on top of my class? If that specific class needs to be accessed from different parts of the application, or if I want to reuse it, I'll go with public keyword on top of my class. Then on the methods, so use public for methods that form the API of the class. So if suppose I have a REST controller, and inside it if I'm trying to write a method, that should be public. Only if that is public, then only I will be able to access it from the outside world. So these methods are called by the external classes. So any other class can call the methods that are defined as public. Next is field accessibility. So it's good practice to avoid public for the fields except for the constants. So it's always good not to use public except for the constants. If you want to access that specific field, you can encapsulate it using a setter method. Other than that, it's always good practice to avoid using public. Next, for the interfaces. So with the interfaces, as we all know, all the methods in the interfaces are implicitly public. So these methods will be implemented by the class that is overriding it. And next comes the enums. The constants in the enums are by default public, but if we want to declare the entire enum as public, yes, we can do that by providing it by providing the public keyword. But other than that, the constants that are defined in the enums are public by default. So the next question, what are lambda expressions in Java? So lambda expressions, which were introduced in Java8, it became a powerful feature after Java8, and it enables us to write code more concise and in an expressive way. And mainly we will use lambda expressions to deal with the functional interfaces, because functional interfaces will have only one method, and to override that method we often use lambda expressions. And lambda expressions are nothing but a short block of code. It will not have a method name, it will not have a return type, it will not have anything. It's just a short block of code, and that accepts parameter and returns some value. So that's where we are using lambda expressions. Lambda expressions, in other words, they used to say that these are nothing but the anonymous functions without name, without return type. We can define a method, and that's nothing but the lambda expressions. It accepts a parameter and returns a value. And we will use lambda expressions mainly in our code when we process streams, because this is an effective way to process the data in these streams. And some of the common use cases that's already available in some of the common use cases where we can use lambda expressions, or to override the functional interfaces such as runnable and the callable interfaces, comparator and comparable, while we sort, and predicate, consumer and function in the util function package. In all these cases we will use lambda expressions often in our code. And when it comes to syntax, it's very simple. Parameter inside the parenthesis followed by an arrow and the expression that we need to define. When it comes to benefits, the lambda expressions are really beneficial in terms of conciseness. It's because it reduces the boilerplate code and readability. When we use lambda expressions to express the functional programming, our code become more readable. And also when it comes to collections or stream processing, when compared to the traditional method, lambda expressions makes the code more readable. So lambda expressions brings in the functional programming concept in the Java, and significantly improve Java's expressive part and flexibility. So what are the dependency scopes in Maven? So to answer this question, we need to know what a dependency is. So dependencies are nothing but that is required. Those are the dependencies that are required to run an application. So if we are adding a dependency, so in which specific phase of the software development cycle we need that dependency. We can need that dependency during the runtime. We can need that dependency in the compilation time. We can have that dependency during the testing, which is only while running the test cases. We need certain dependencies to be injected by the container. So we need to define when all these needs to happen. So define mainly the dependency scopes are nothing but to determine the life cycle phase in which the specific dependency should be available. So For few of the dependencies, if we just need it in runtime, we don't need to include it during the compile time. So we need to manage those dependencies efficiently, and mainly for that we need the dependency scopes. So we have like nearly 6 scopes in the Maven dependencies, and the first one is the compile scope. So if you see here in a dependency, this is a dependency. If you see here, we will provide the group ID, artifact ID, version, and along with that we need to define something called scope. And for the compile scope, we need to provide the compile keyword. So compile scope or nothing but these will be available during the compilation time and during the runtime. So the dependencies are included in the class path during both the compilation time and the execution phases. Next is provided. Provided is like the difference in syntax for compile scope and provided scope is just that in scope we will provide provided instead of compile. So in syntax wise, it's just scope, provided scope, and it is very similar to compile scope, but this dependency is expected to be provided by the runtime environment, meaning it is available during the compilation, but it is not included in the jar file that we create while running the application. It is assumed that that jar will be contained provided by the container or the runtime environment. Next comes the runtime. Runtime, it's very this is like straightforward dependencies that are required for runtime but not for the compilation time. Next is test. As I told earlier, these dependencies will be used only for the testing purposes. While executing the test cases, we will need these dependencies, and those are not needed for the normal compilation or execution of the main application. Next is system. System is very similar to provided, but in provided we assume that the container or the runtime environment will provide me that jar, but provide me that dependency. But for the system, it should be available in my local system. It is not expected to be downloaded from the remote repository, but instead it should be present in my local system. For those type of dependencies, we will provide as system. This we will provide the jar manually. Next comes the import. This is a different scope when compared to all these five. Why? Because import, we will use this import only in the dependency management and not in the usual dependencies that we use in our application. And it is mainly used in the dependency management section to import the dependencies managed by the another POM. So my dependency is managed by the another POM. I need to import it to my current project. For such scenarios, I will use import scope in my dependency, that too in the dependency management tag. This is the main thing that we need to explain when it comes to dependency scopes. It's mainly to determine the life cycle phase in which my specific particular dependency should be available. So let's discuss the next question. What do you know about Spring Core and Spring Bean? So Spring Core, it is nothing but a foundational module for the Spring framework. Spring Core includes core components, Bean, expression languages, AOPs, and few other modules. So overall, Spring Core is nothing but the foundational module for the entire Spring framework, which provides the functionalities and the essential features for the other modules in the Spring framework to work. Suppose if we are using inversion of control or the dependency injection, which is nothing but the Spring Core module, that the fundamental components that the Spring Core provides, all these will come in the Spring Core. So which and all is required for the development of the enterprise applications using principles like inversion of control or the dependency injection comes under the Spring Core. Next, what is Spring Bean? Spring Bean is nothing but an object that is managed by the Spring IOC container. It's a straightforward question. Spring Bean is nothing but the classes or the components that we create in our application. So we can say our service classes or the repositories or all the various components of the Spring Bean, or the classes which are nothing but the Spring Bean. So our entire application, that is made up of the Spring Beans. So Spring Beans is nothing but that is an object, and those objects are managed by the Spring IOC container. So beans are created, configured and assembled by the IOC container based on the bean definitions provided. Obviously, for our services or our repositories or any bean which I'm creating, I'll provide the definition in which way it has to provide, like in which scope. For example, it is whether it is a singleton bean or a prototype bean. So I'll provide a few definitions, and based on which my Spring bean will get created. So Spring Core and Spring Bean, it's like it's not like a difference between question, but what do you understand by it? Spring Core is a foundational module, and this is required for the this is the base thing for the entire Spring framework. Spring Bean, it's nothing but the classes that we create, beans that we create. It's nothing but an object that is managed by the Spring IOC container. Spring Bean is like a building blocks. Why it is a building block? Because mostly application will have controller classes, service classes, repositories, and all or nothing but beans. So these are the building blocks of the Spring application. What are the modules in the Spring framework that you have used in your application? You have to mention the modules that you have used in your application. I have mentioned the modules that I have used in my current application. So you have to mention yours. Anyways, I'll explain you how you need to answer this question. So first I'll say Spring Web MVC, because this web module, the Spring MVC module, this focuses specifically on the Spring MVC framework, and it's powerful and a flexible module. Whenever we create the APIs for our application, obviously we will use Spring MVC dependencies in our application. So this is mainly used for building the web applications, and it includes the controllers, view resolvers and other components for handling the web requests. So I have used Spring Web MVC in my application. Then comes the Spring AOP. So AOP, as we know, to implement cross-cutting concerns in my application such as login, security, transaction management, to separate the cross-cutting concerns from the main business logic, I have used Spring AOP in my application. And next comes the Spring JDBC. For the JDBC is nothing but the Java database connectivity, and I have used Spring JDBC module to simplify the database access using the JDBC API. So also this JDBC provides a common abstraction for the common database operations, exception handling, and to support the declarative transaction managements. So while using Spring JDBC, it's easy for me to handle the database related exceptions. So we are using Spring JDBC in our application. Then comes the Spring Security. Any application that we develop, that should be secured. So we are using Spring Security in our application to implement the Spring security related things like authentication, authorization, and to protect it from the common security vulnerabilities. Next, we are using Spring Data in application. So Spring Data we are using to simplify the data access in our application, especially from the relational databases or the NoSQL databases. Next is Spring Transaction. So Spring Transaction we are using to provide the support for the transaction management in our Spring applications. Next, the Spring Core Container. Spring Core Container is a as we said, it has the foundational features, and this helps me to create the beans using the bean factory or the application context, dependency injection, or the inversion of control. So this is the main foundational thing that that I use in my application. Next comes the Spring Web Flex. So for the reactive programming, to support the reactive programming, we are using Spring Web Flex in our application. It's not necessary that you have to mention all these. You can mention what and all you are using in your application. What is the difference between inner join and the outer join? So this is a very basic question that was asked for the screening round related to the database. So let's whenever a term join comes, which means that multiple tables is involved or more than one table is involved. So in the relational databases or in the SQL, inner join and the outer join or the join operations, which is used to combine the rows of the different tables based on a specified condition. So what is a inner join now? Inner join is nothing but if suppose I have two tables and I am trying to join those two tables, only it will return only the rows that have matching values in both the tables. If not, it will not return that row. Suppose I have an employee table with employee of department id 1 2 3 4, and I have one more department table wherein the department ids is just 1 2 3. Inner join will return only 1 2 3 department id's employee to me. Why? Because inner join will return the rows that have matching values in both the tables. Next come the outer join. So outer join is of two types, left outer join and the right outer join. If we use left outer join, what will happen? It will return all the rows from the left table and the corresponding matching rows from the right table based on the specified condition. If suppose there is a there's a row in a left table but there is no row in the right table, what will happen? It will return null values for those columns from the right table. Suppose my left table is department and I have IDs 1 2 3 4, and in the employee table I have IDs just 1 2 3. So if I use left outer join, it will return all the four rows from the department table, and for those columns of the employees in the join result, it will return null. So left outer join returns all the rows from the left table, and like based on the condition, and if there is no match, it will return, even then it will return the columns from the right table, but with a null values. What is right outer join? Right outer join is similar to that of left outer join. Instead of returning the rows from the left table, it will return the rows from the right table. So let's assume I have my employee table in the left now, and I have values as 1 2 3, and in my department, as I already told, 1 2 3 4, it will return all four IDs of the department from my right table with the corresponding null values to the left for the employees. So that is called as right outer join. Right outer join, what will it do? It will return all the rows from the right table and the matching rows from the left table. If there is no match, what will it do? It will return null. So this is a very basic question, but just it's a screening round, it was asked. So next question, so are you aware of the NoSQL databases? Do you know when to use SQL and when to use NoSQL databases? So SQL databases we need to use when we have a structured data. We already know what our data is and it's structured. And for the complex relationships like many to one relationships or one to many or whatever, for the complex relationships, and for a transactional consistency. So for all these situations, we need to go for SQL databases, and few of the SQL databases are MySQL, PostgreSQL, and Oracle. And for the NoSQL databases, that's suitable for scenarios where my data is unstructured. I don't know what I'll get, what response I may get, or how my I won't be able to structure my data. And the scalability is crucial. It's because it's easy to scale NoSQL databases, and flexible. I can use a flexible schema. In all these cases, I can go for the NoSQL databases, and NoSQL databases is gaining popularity. And few of the NoSQL databases are MongoDB, Cassandra, and Redis. So this is the SQL and the NoSQL databases, but the choice of choosing between SQL and NoSQL depends on the requirements of the application that you use, like the nature of data, whether it's structured or not, and the desired scalability, like how crucial the scalability of the data is involved in your application, and how flexible is your data, whether you need a schema or not, you need a flexible schema, or how flexible is your data. Based on all these after analyzing all these all these, we need to choose which database we are going to use in our application. In many cases, nowadays a hybrid approaches has come, and which is nothing but a NoSQL, wherein we can combine the features of both SQL and NoSQL databases. So with this, we have reached the conclusion of this video, and in our upcoming videos, we'll discuss in the questions of the level 1 and the level 2. So please stay tuned to hear those questions and for the more insightful discussions. If you have any specific topics, questions, or areas you would like to explore further, please feel free to leave a comment, whether it's related to the interview questions or whether it is related to the any specific topics in Java, Spring, microservices architecture, or any other tech related subject. We are here to help and discuss. Your input means a lot, so please don't hesitate to share your thoughts in the comment section. Also, please don't forget to like, share, comment, and subscribe for the future updates. Thanks for watching and see you next time.